apparently, because I think Mark just started that. You can replay the previous month's program, and then we will be putting archived copies up elsewhere so you can go back to other programs that are more than a month old in the near future.
Comment?
Go ahead, Charlie.
Yeah, I just want to complete what I was saying because I forgot. But anybody who would be interested in joining our club, it's important to recognize that the club maintains a variety of repeaters on Palomar Mountain, and all of that is maintained through the yearly dues to be members of the club. And I will turn that over to our president to address the gigantic cost of that membership.
Yes, so our membership is $35 a year for individuals, and that helps to support all of the endeavors of Palomar Amateur Radio Club. We do run several repeaters up on the mountain, 3 on 2 meters, 1 on 440, and we have several 220 repeaters that are hosted at our site from other clubs. So we are definitely active in the San Diego area, and our repeaters are used to support various emergency communications. One of those is the Oceanside CERT communications team. They use our repeater as a backup for their net and for their activities, and they actually had to use it this past week. So when they went for their normal net on Sunday evening, their repeater decided that it wasn't going to repeat. So they immediately all switched over to the Palomar Club repeater, and they were able to hold their net because they have that procedure in place to use that as a backup when they can't hear each other. So that's fantastic that they were able to make use of that, and that we are able to continue to provide that vital service to this emergency organization. Ron, I see that you're on K2RP. We're in the announcements time, so this would be an appropriate time for you to go ahead and unmute and talk about what you have available. So that's fantastic that they were able to.
Okay, somebody's still talking. I don't know who it is.
So Ron, if you're on the palomararc.org/live, then you're also playing the YouTube version. So just go to that webpage and just pause the YouTube version of it.
Okay.
There you got it.
Am I okay now?
Yeah, you're okay now.
Okay, I don't see anything now, but as long as you see me. Yeah, it's good to see everybody. I haven't been able to make the last couple of meetings, but one thing I was telling Joe is I was able to get a big pile, maybe 30 or 40 of those 4-foot fiberglass military type masks that are swaged at the end to put them together, which I would love for our members to have, as many as they want. Right now they're in the back of my Jeep, and I would like to get them all out of there, either to club storage or somebody's house. But in the next few days, I got to get them out of my car. So give me a call at 760-436-8109, 760-436-8109, and or email K2RP@ARRL.net. We'll make arrangements there in Encinitas. I also have a couple of older 2-meter mobile type transceivers that I picked up. Haven't checked them. Anybody wants them can use them, especially if there's a new licensee or a youngster who wants them. They're welcome to them. And I think Joe will tell you he may have some left that I gave him some handhelds as well. Okay,
Ron, give me your phone number again.
760-436-8109.
All right. At least in the meantime, I can put them in club storage with you.
Where's?
So I'll give you a call. I'll give you a call after the meeting and we'll arrange getting it in storage, and then
Right,
people can come get them out of storage at their leisure.
right. Thank you very much, Mark.
Probably inappropriate to have your car taken up for till everybody decides they want them.
No, it would not be.
All right, we'll get that squared
Okay.
away in the next day or two.
Thank you.
Thanks, Ron, and thanks, Mark, for taking care of that. So for those of you who may not have noticed in the scope yet, we have awarded our first scholarship from the Palomar
Yay.
Amateur Radio Club Scholarship Fund. So there's a lot of information in the scope about our recipient. Her name is Jackie, and her call sign is KK6OCG, Oscar Charlie Golf. And she is attending University of California, Berkeley, majoring in meteorology. So you can check out the scope for a nice long article submitted. I believe Charlie put that together. Is that right? NN3V, was that your you putting that together?
Yes, it was me, and I must correct one item in it, and it's kind of a long story associated with the scholarship award organization. Everything in the bio is correct, except that she's majoring in electronic engineering.
Okay.
Long story. I heard somebody make a comment.
That was me. I said yay.
Yeah, she is.
I went to Berkeley too.
She is majoring in electronic engineering at UC Berkeley. That is correct.
Great. Okay. Well, thank you for that correction, Charlie. And yeah, that's great news. You can look at everything else in the article in the scope. The scope is available via email if you get that, and you can also see previous month scopes if you go to palomararc.org and click on the newsletters link. I have updated that today with a couple that were missing. Okay, I believe that is all that I have for announcements. Does anybody else have any announcements about upcoming amateur radio related news? Oh, I do have one more. I have two more, sorry. These are in the scope as well. Next month is going to be our auction. We are going to have the auction. It is going to be via Zoom. It's going to be a lot of fun, we hope, and it'll be an experiment at least. In order to participate in selling for the auction, you need to send photos and clear descriptions of your items to a new email address that we've created, auction, AUCTION, at palomararc.org. We need a good couple of clear photos and a good description text block of what you're selling, and an opening bid or a do not sell under bid or under amount. And we will put those together. We need those at least 7 days before the meeting in order to put together the PowerPoint presentation. During the pre-meeting time, we'll be running a slideshow in the Zoom session so that people can see everything that's going to be auctioned. Things might go quickly, so you got to keep an eye on it. And then during the meeting, we'll hold the auction just like we normally do, and hopefully we can manage to not get too many people angry about, oh, I said I wanted to raise my bid after someone said going, gone. So it'll be an experiment. It'll be fun. Hopefully we can get some equipment relocated. We have yet to determine how we're going to actually disseminate the equipment. The suggestion has been that we have a drive-through equipment swap situation going on. So like on the Saturday, like 1 or 2 Saturdays after the meeting, we'll have our equipment set up at the location of our normal club meetings, and people will drive in the morning, drop off all of the equipment that they sold, and then in the afternoon we'll have people driving in to pick up the equipment that they won. that's one idea that we've thought of. There may be some shipping options too. Your board will continue to discuss the details of that and get back to you as soon as we have decisions. Okay.
Is Bob
any other
the auctioneer?
Mark, did you talk to Bob yet?
I have not talked to Bob yet.
Is
He's
Bob
on.
on here? Hey, Bob.
Yeah, Bob's here.
How do you feel about virtual auctions?
I'm virtually excited.
Virtually excited. Okay. Well, I'd say
Not
that
really excited.
I'd say we go ahead and between Mark and Bob, we can, get an auctioneered out. At least this time we don't need runners to lug equipment around. So
Yeah,
that's one thing. Okay.
I guess the the main point on this is, that to get a couple good, just cell phone pictures and a good little description and send it in to auctions at Palomar ARC so that we've got enough stuff to make this worthwhile. So this is going to be the standard, take the junk out of my garage and put it in your garage so that I've got room in my garage to buy more junk from somebody else. Next year, I will be selling that junk. Isn't that how it works?
That's right.
An old tradition.
All right. I think this is going to be a lot of fun.
Yeah.
I'm bringing my water.
you pay with virtual money.
Comment.
Go ahead, Glenn.
I see that Henry, WA6AUP, has his hand up in the Zoom window. Did you have something you wanted to share, Bob? Sorry, Henry.
I don't believe it's me. I don't have a camera functional. So you might pick another name.
Okay. Well, it just shows your name on the screen, and in the participants window, it shows that you clicked on hand up. So that's why I was checking with you.
Yep, I see that too. Okay,
Right.
Thanks, Glenn.
Yep.
All right, any other questions, comments, announcements? Okay.
One comment is, I think Charlie sent it out to us, and that's the discussion or question about the FCC reinstating or not removing the exemption for amateur radio operators. Otherwise, it's a $50 fee, and I didn't quite get whether that was I think it said it was not an annual thing, but it's, I guess, if you want to get a license, it's going to be 50. If you want to get an upgrade, it's going to be 50. So take a look at that in the scope and read it and go to the website and check it out.
Yep.
Something we need to
comment
on. Sure.
Go ahead.
comment. So I understood that it was $50 for any change. So new license, change of address, upgrade was 50. To reissue and license was like $20 or $15 for the documents.
I think it said actually if it wasn't for anything you could do directly online, like a change of address, wasn't going to be charged for.
And just to keep this in perspective, if it's a 10-year license for $50, it's 10 cents a week.
Comment.
Yeah, Charlie, go ahead.
That is not a rule at this time. That is an announcement from the ARRL that the FCC is considering that rule in order to meet the direction from Congress that the FCC charge for all of their services what they call the going commercial rate. And the FCC has generated a proposal for rulemaking, which will be open to public comment once it gets through the bureaucratic layers. And one of the things that the FCC has indicated is that in order to maintain the extensive database of silent keys, of amateur radio operators and all their licenses, it will cost $50 per action for renewal and the award of a license. So that's what this is all about. Pay attention to the opportunity to comment on the rulemaking proposal when the time comes.
Thanks for clarifying, Charlie.
Okay.
Another comment, please.
Sure, go ahead.
It's going to be interesting to see how many 1x2s and 2x1 calls that are held by some individuals, 10 or 12 club calls, or when they have to pay $50 each for them.
Like ours.
Yeah. All right. Okay. Anything else? Then we'll get on to our reports. Mark, repeater technical and site report.
Everything is melting up there, but the new fan is working just fine. The repeaters are all just fine. You might be interested to know that last month at the board meeting, I was asked to look at DMR. So part of the deal was I have bought a DMR interface modem for one of our repeaters. I've already contacted Bernie, who was interested in working on it, and he's in Utah right now. But he's I've gotten the manuals, and he's curious. So we're looking at the best way to integrate DMR into the repeater system. Other than that, not a whole heck of a lot going on.
Great. Thanks, Mark. Glenn,
No.
membership?
They'll call me back.
Yeah, so we currently have, if you look at the website, it says we have 158 members, but I have 10 updates to do. Some of those are probably people whose memberships expired, and so they're quote unquote rejoining, and that will bring that number up. So we're somewhere between 166, 168, something like that for membership right now.
All right. Good deal. Okay. Tom, do you want to talk to us about money?
I'm looking to WebEx or Zoom.
Tom, W0NI, do we have you there? I see you on, but you're muted.
Howard, KY6LA, go to mute.
All right, I guess Tom had to step away. Okay, so we will introduce your board. So Mark, who you just heard from a moment ago, KF6WTN, is your repeater site and tech chair, also the host of the meeting, and has the woodpecker behind him. Glenn is your membership chair, AI6RR. Your scope editor, Keith, I didn't see him on yet. Cam6CXW, I think it is. Greg, KI6RXX is on there, I saw as one of your directors. Joe, KB6NMK is the other director. Tom, W0NI. John, WV6IQS is your secretary. Charlie, NN3V, who you heard from, is your vice president.
And my apology for no camera. It was working an hour ago on a different Zoom meeting, so I don't know.
It happens, Charlie. And I am Joe, K6JPE, your president. So we had announced that this topic would be, well, actually, I'll go ahead and turn it over to Mark, KF6WTN, and you can discuss the topic.
What?
Well, pardon me?
Okay, I'll turn it down.
Okay. All right. So after that, what happened is we ended up with some crossed wires in a wireless club. And we unfortunately do not have the person presenting the woodpecker tonight. So we found this out about an hour and a half ago, which wasn't really enough time. So I told Joe, I said, well, right now we have 30 people. Let's see how many of them run away when I say that I'll do something. So we have an interesting opportunity here. I have several presentations that I've done in the past. One of them that came, and by the way, there is something else besides me talking. One of them was an introduction to all battery technologies. You name it, prismatic, cylindrical, numberings and lettering systems for batteries, how the voltages are created, everything you always wanted to know about batteries, but we're afraid to ask. So that's one.
Comment,
Go ahead, Charlie.
Mark. Sorry, I just want to interrupt to say, yes, we had a problem with scheduling of the presenter, and I will endeavor to get it rescheduled. So those who were hoping to see that presentation, which has very, very high mark for its quality, I am going to dedicate myself to getting the presentation scheduled again on the correct date.
Okay, I also have, anyway, I did that one a long time ago. We also have all of the Tech Corner presentations, which how do A to D converters work, how do FPGAs work, what's GNU radio about, introduction to radio and PARC's facilities, which is a big one. What's the difference between OLED screens and LCD screens? What's Skywave and RF skip? What's universal serial bus or USB? What is VPN? And if I might even get some help, what's SDR? So there's those. And then the last option is we've got a lot of technical people in the room. I can simply moderate a technical question and answer period. You know, we've got a lot of people with a lot of experience. One person just gave up, hung up on me. I guess what I want is to know what you guys are interested in tonight. Like I said, we only knew about this like an hour and a half ago. So this is the best I was able to do. And you know, I've got things I can do, but what are you guys interested in?
Comment?
Go ahead, Charlie.
I would offer that it's an opportunity for some of the people who have joined because they were invited outside of the club. Some of them may not be as advanced in their knowledge of radio and electronics. They may want to suggest a topic they'd like to know more about, and we can proceed to answer that.
Yeah, that was the idea of the question and answer period, the last option.
Sorry, I missed it.
Whatever you want to know. So what does everybody think? I see everybody is muted. Somebody's got it. Oh, I got two chats. Go ahead.
This is John, WB6IQS. I was going to comment. I bought a Anytone DMR analog radio, and I started getting into it, and I found out that the operating system has to be reinstalled, and the what they call the code key or the code plug is got to be installed. Anyway, the long and the short of it is that it's like about a 2-hour process to figure out all the stuff that needs to go into a little handheld radio. So I just going to make a comment about modern technology and the Star Trek technology being about the same sort of thing.
A comment to back that up.
Go ahead.
I think the question that that John has asked is an exceptional one. Anybody contemplating getting into DMR needs to realize that it's a steep learning curve. I would offer that one of the topics I'd like to hear about is how do you call CQ on DMR? It is very different from RCQ.
I was anticipating the code plug, and I was anticipating, a learning curve, but then I found out that I've got to download like 5 or 6 megabytes of operating system, and my experience with reloading BIOS in computers and things like that has not been very good. So I'm going to probably have to take it to somebody that's done this sort of thing before.
It is fairly simple. If you log on to the Anytone website, also is known as the, I can't remember the name of it. It's an outfit in Washington State that is their American counterpart. You do have to RTFM, read the funny manual in great detail. I found once I understood what they wanted, you push a button and Windows 10 gets everything done. But from there, programming a code plug, good luck. You need to find somebody who has done it and they can explain it to you.
All right, tell you what, not having heard any opinions from anyone or anything on the chat, I guess by default, I'm going to talk about batteries. Does anyone want to argue with me?
No.
Well, at least I got one. Somebody's awake. So let me see. I hit this button called share screen. Voila. Now, there's another button here, the infamous F5, that makes it, I think you can go full screen. All right. Ta-da. Can everybody see that?
Yes.
Okay, that's a good sign. All right, so this, like I said, we're gonna, since everybody has the ability to talk, we're gonna make this hopefully a little bit more interactive than the last time I did it, somewhere like 3.5, 4 years ago. So we'll see how this works. When we talked about this, I noted that I went and found the world's largest battery. And what I did is I looked up the largest super tanker in the world sitting next to a regular tanker. And the reason why I call that the world's largest battery is because a battery is simply an electrolyte with dissimilar metals, such as, Joe, since you're on your boat, one has bronze and stainless steel hardware, and you get current flow to the one that has the aluminum stern drive. The return path is the ground. And the electrolyte is the seawater. So here we have the same thing. The only difference is we're using cupric sulfate and zinc sulfate with a salt bridge here. And voila, you generate voltage. It's a battery. So the question is, how do you know what voltage your battery is going to be? Whoop. So it turns out that these materials have what they're calling reduction half reactions. When aqueous lithium loses an electron or gains an electron and becomes goes from an ion to a complete lithium atom, it turns out it takes about 3.04 volts to get that reaction to happen. So then what you do is you got to have another electrode somewhere up in here. You add these numbers together, and that's the battery voltage. So you'll notice, for example, lead. Let me see where PB is. There's lead. May not be too good. But then when you start looking at the other material up in here, which is probably manganese or maybe a chloride, all of a sudden you end up with a voltage that's a little bit more reasonable. Same thing with nickel, with cadmium, with iron. The old original Leclanche cells were actually zinc and carbon zinc batteries. So this is how you figure out what battery voltages are going to be. We like lithium. So the next subject is some of these, the reaction that we saw. Oh, somebody is chatting with me. Okay. I don't know what that is, but okay. Anyway, so the reaction that we saw, some of these reactions are reversible and some of them are not easily reversible. So the ones that it's a single use throwaway, we call those primary cells. The ones that are rechargeable, we call them secondary cells, at least in the business. Typically, the secondary cells also usually have a little tougher structure because you end up taking the metals and dissolving them into solution and then replating them. So as a result, you can end up getting a little bit more energy density out of the primary single-use cells because they know they're never going to have to plate the material back onto the electrodes again. So in here, you know, nickel metal, we don't use this as much. We still use lead acid in cars, although now I'm noticing lithium iron phosphate car batteries. They're still up around the $700 to $1,000 range, but they exist. And of course, rechargeable nickel metal hydride, lithium ion, lithium polymer. Single use, everybody has the good old alkaline. The lithium cylindrical cells, don't use those as much, the lithium iron sulfate. Everybody uses these, the little flat ones that look like a quarter, lithium manganese dioxide. Those little flat ones that look like, they're a little bit bigger than a quarter. We'll talk about the size here in a minute, because there's a standard for that too. Speaking of standards, it's almost like I know what the next slide is going to be, right? Speaking of standards, there are standards for AA, AAA, quadruple A, CD, 9 volt. And then there are some numbered ones that we'll get into. These CR, 4-digit, 5-digit, and of course the ever popular CR 2032 will be in here.
So these are mostly size designations, correct?
Yes. The infamous 9 volt there. And these are other names for a 9 volt.
Hey, Mark, this is Keith.
Yeah, go ahead.
I just thought I'd say hi. I recognize that antenna behind you.
Oh, well, thank you.
Huge antenna, the Woody Woodpecker antenna.
Right. Okay, I was kind of in the middle of giving a little presentation here.
Oh, I'm sorry. Go ahead. Keep going.
No, that's quite all right. Anyway, so this is not what you're used to seeing. You're used to seeing this one, which is little button cells, and also, you know, I may even have a couple in front of me. Oh well, things like the 18650s that are very popular in flashlights and things. So here's the breakdown for these. The first letter is the chemistry. So when I use a CR2032, which happens to be that little round battery that's in, you know, little tiny thermometers and whatever, they all use CR2032s or CR2016s or whatever, 2025s. The C is the chemistry that it's going to use. Lithium, the material, the electrode material is manganese dioxide. The other ones that you're used to seeing, the LR44, LR whatever, LR, those are alkaline batteries. The S you don't see as much anymore. Silver oxide batteries, nice, very even voltage, pricey. Typically the people freak out when you throw out a lot of silver. And then for people with hearing aids, the zinc air batteries, which start with a P. The second letter on these type is always an R, meaning radial battery. Okay. Then we've got a 2 or 3 or 4 digit code. So the first digit is the nominal diameter, and I don't remember the tolerance. So for example, the 20 is 20 millimeters in diameter. The 44s are 4 millimeters in diameter. And what I have some that are 24s. They're the key fob for my car. Uses a flat lithium manganese dioxide cell. Big sucker. And then the next digit after this, like a 2032, I'll just, because I don't have a slide on that, is the thickness of the battery in tenths of a millimeter. So a 2032 is going to be 3.2 millimeters thick. I have a 24, I think 75 or something like that, or 2450, which is like 5 millimeters thick. Big old sucker, not quite as efficient, 10 times more expensive, but you know, that's what they wanted in the key fob. They seem to last about 2-3 years each. And there is Keith Snyder. Hello, Keith. I've been vamping.
You have been. I wasn't sure if you knew who I was.
I just recognized you when you appeared.
Oh, okay.
Ladies and gentlemen, Keith is the man that was supposed to give the presentation tonight.
Oh, look, you know, batteries are making me electrified.
I'll tell you what, I can do this real quick, and then we've got time for yours because you're only supposed to start a few minutes ago.
All right. Well, I'm still alive, so no problem.
All right, give me just a second.
Take
So the other difference is cylindrical or radial versus prismatic batteries. In the case of radial batteries, they're wound around a bobbin, and they usually have a little nub on the top. They've got a gas vent release. We'll talk about the PTCs. There's the negative side. There's the positive side. Makes life pretty simple. I'm trying to skip through this quickly now. This happens to be a Sanyo battery. These were x-rays of wound, or they sometimes call them bobbin batteries, that have a fault in them. And you can see where they wound them and there was a fault. All right. Okay. Who's got their background TV on? Okay.
Yeah, please mute yourselves if you're not supposed to be talking. Thank you.
Okay. Now a prismatic battery is one that's flat. For example, all these coin cells are prismatic, meaning that it's just a single layer. So this gives you an idea. There's the little gasket seals all of these little coin cells. The separator material. There's the cathode material, the collector, and the anode material. Ta-da. There's the anode cap. So anyway, so a lot of the old cell phone batteries, back when they were replaceable, were prismatic batteries. So flat, multiple layers, the electrode on the end. Now what I did, here's a X-ray of one. This is not an X-ray I did, but I used to have a really cool microscope. Oh, for those of you who aren't familiar, to get higher voltage, you wire all your batteries in series. This one goes to that one goes to that one goes to that one. And these are 1.5 volt cells. So you get 6 volts at whatever the current rating of a single cell is. On the other hand, you can parallel a lot of them. And what you end up with is 1.5 volts at 4 times the current capacity. Now, some of you guys know I have a Tesla, and it's pretty interesting. It uses lithium ion batteries at about 3 to 4.2 volts, depending on charge level. They put 100 of them in series to get between 300 and 420 volts. And I never figured out how many are in parallel, but the packs are like about 2 feet by a foot by the thickness of the batteries. And the whole bottom of the car is filled with these parallel arrays of 400 volts batteries. I don't think we need to talk about load balancing. It's just a way to balance out loads. If anybody's curious, it's a way to balance out cells. I actually designed one for our big battery array that we have up on the mountain. And one of these days I'll talk poor Glenn into helping me program it, because for some reason he has more time than I do, I think. All right, so when you want to charge and discharge capacity, batteries, you refer to the capacity of the battery, C. That is defined as the capacity of the battery if you drain it over a period of 20 hours. And this is an industry standard. So when you talk about batteries, then you determine how fast can you discharge the battery. Well, I can discharge it at C times 10. So if it's a 3000 milliamp hour, 3 amp hour battery, C times 10 is pretty crazy. That's 30 amps. I've seen C times 5 out of some of the lithium polymer batteries where you can discharge them at 15 amps, which is pretty crazy. And then charge time. They'll tell you in the battery spec, how fast can you discharge this battery? Or how fast can you charge it? Okay, so this just, and I'm trying to go through this quickly, guys. This just gives you the energy density of the different materials, internal resistances. They define life cycle as 80% discharge, and this is the number of cycles that the battery can withstand full charge to full discharge, end to end, one after the other, and it's usually at C over something, like C over 10, or they'll charge it at C over 10 and they'll discharge it at C, the capacity of the battery. And what they do, you'll notice that some of the batteries here, they're being generous. Normally, most people, for the standard lithium battery that we use in all our flashlights and cell phones, they rate them at 400. That's full charge to discharge rates. Guess what? If you discharge your car battery all the way, it's not going to last very long. They don't like that. NiCads are pretty good, but look at these lithium iron phosphate batteries. And some of the ones I've got, like right next to me here, they're claiming 10,000 cycles now. So those are tough little buggers. Anyway, we can talk about this some other time. I want to get back to the care and feeding. Why don't we drop this? Keith, are you ready to start, or do you want me to vamp for another minute or two?
I'm ready to start anytime.
Hey, watch this.
Now, the only thing is, can I get hold of, let's see, one thing I need is share the screen, but the other thing is to make sure that the audio is on my computer.
Okay. Right next to share screen is that little green up arrow. You'll have to click it after you share your screen.
Okay.
And then it'll ask you to share your computer audio too. And I guess the answer is go for it.
Okay. Under more, and I'm not sure, tell you the truth. I'll tell you what, the audio is kind of interesting. So let's see, you're saying I'm sharing the screen, and then where would I do the audio, share audio for the computer?
It's share computer audio, but if it only, I can't see it right now because I'm not sharing my screen, but it says down near the bottom of the little menu, it'll say share computer audio.
I think that's on the main share screen before you, like when you first hit share my screen, it gives you a preview of what you're going to share. And before you actually hit the, yes, this is what I want to share, it gives you share computer audio.
Okay. Okay, let's see. Well, okay. That I thought record meeting, disable, blah, 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 hide copy.
I think you have to stop your share and then restart it. And during the time when you're restarting it, that you'll have a checkbox to share computer audio.
All right. Okay. You guys see my screen now, okay? And then I'll optimize this. Let's see. I'm going to go to here and here. Hopefully it's. Oh, I see here. Hold on. Okay, so it does have audio. Okay, so let me go ahead and start. I'm sorry I'm late a little bit. I want to get you out of the fog here. This talk is about the Russian Woodpecker Over the Horizon Radar, which is a blast from the past. And I call it a blast from the past because A, it was near Chernobyl, which blew up. And it was also blasting the airwaves. So it was blasting the ham radio airwaves. And that was not good at all. So you can understand that when you're on ham radio and you hear this peck, 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 it's not good. So let's take a look at this thing. This is a picture during the winter, and I'm going to show you Fedor Alexandrovich's first impression. Fedor is a person who was actually radiated by the nuclear power plant when it blew up, and he had health problems, issues, and he was trying to find out, why did this accident happen? Why did Chernobyl blow up? And was this antenna related to it? So here's the introduction. This is where he first sees the antenna, and you will have to imagine seeing it for the first time.
Мне трудно говорить, потому что то, что я вижу, это не человеческое творение, это творение империи. И эта груда железа была грудой железа бесполезной уже тогда, когда строилась. Не тогда, когда была построена, а в процессе строительства не существовало теоретической базы для ее работы, и она уже работать не могла. Отсюда доносился стук русского дятла из этого железного занавеса. Этот железный занавес – это глаз Москвы, так его называют. Глаз Москвы, который находится рядом с атомным сердцем, с Чернобыльской станцией, с сердцем Советского Союза. Глаз Москвы, который был слепым. Эта конструкция не работала. Есть ли связь между слепотой этого глаза и разрывом атомного сердца? Как-то оно все совпадает, но загадочно. Потому что для меня это огромная трагедия. И у каждой трагедии должны быть свои причины. И случайностей не бывает.
So there you see the Chernobyl right through the antenna. So what we're talking about tonight is a man-made interfering signal known as the Russian Woodpecker. And the sheer size of this antenna is just tremendous. We'll look through some of the history of this antenna and see some of the secrets that were behind this irritating noise that was basically broadcasting from the 4th of July, 1976 until 1989 when it finally went off the air. And it's called the Duga 3. And it had many names, Duga 1, Duga 2, Duga 3. And people were always trying to hide the fact that this was a transmit antenna rather than a receive antenna. And it's right next to the Chernobyl nuclear power plant. Very irritating, very, very irritating, especially if you're a ham radio operator and getting blasted away with the signal. The purpose of this Duga 3 was just to make sure that the Russians had 25 minutes to respond to any missiles that were launched. These are nuclear missiles pointing at the Russians, and this particular site was in the Ukraine, using its field of view to help triangulate and make sure they know where these the launches are coming from. If you want to know the conclusion of the story, I have here 3 different antenna patterns, one at 4 megahertz, which is the red one. It's kind of tilted up a little bit, about 10 degrees launch angle right here. And then the next one is 8 megahertz. It launches at about 6 degrees. And then the one in blue is at 16 megahertz, and it is launching at about 4 degrees. And if you look at this antenna, it's so huge. They were planning on moving into the 4 megahertz region. I think that they just spent so much money that they had to cancel the project and send these people home. And they weren't sure if the 4 megahertz was going to work due to the northern lights obscuring the 4 megahertz signals. So they were saying that this antenna was not going to work at 4 megahertz, and that was one of the reasons why they closed down the antenna and the site there. So the site called Duga 3 has 2 antennas. One is the low frequency, and that's the larger array, and one is the high frequency. So the low frequency is huge, and I give you a little bit of perspective on it. It's 150 meters by 500 meters. And if you're aware of dimensions, it's very, very large. The smaller one's 100 meters by 250 meters. And we'll say it started being built in 1972 and was on the air in 1976 and started on the 4th of July. And it took 4 years to build and was on the air for 13 years. So I'm not sure if there's any major flaw with the antenna. I think it was working just fine, but maybe there was an excuse after Chernobyl blew up to take it off the air. But we'll find out more as we go through this. This is the array. Look how large this is. It's 15 by 20. I think it's 300 different cage dipoles here. And these are very, very large dipoles. I mean, look at the pine trees down below, and you'll also see there's sand in front of the antenna. So that's used for ground reflections. It's part of the, it helps the antenna stay constant, and you're going to be bouncing your antenna pattern off of the earth. So you might as well have a consistent dielectric property of sand, and that's why they have sand in front of it. This is what I did in FICO, which is my computer program that I can calculate the antenna patterns with. And each one of these green rectangles represents a football field, a US American football field. So the size of this array is, the large array is 15 football fields, larger than 15 football fields. That's pretty big. That's amazing. From up above at 492 feet, you look down at a car and it's just this little tiny rectangle down here, a little white guy. So it's very, very, very high, and it's very, very, very large. It compared to the Giza pyramid, it's the Giza is 481 feet high and 756 feet wide at the base. So I constructed a Giza pyramid in front of this antenna, and you can see the proportions. It's a very, very large array. So if you look from behind, you can see that it's looking towards the US. You can't really tell from, you know, this photograph, but I can tell from my tools. I used AutoCAD, and I imported this photograph from the web, and I used the angles here of 34.81 degrees west of north. And if you go on the computer, you can find some software that tells you where you're going to reach the United States. What heading do you need to hit the United States? And if you look at it, that particular angle, you can see it's 302 degrees to Miami. This is from the Ukraine, and it's 339 degrees to San Francisco. And that particular angle that I called out there is going right down the pipe, right down the United States. So it's pointing directly at the United States. And if you look a little bit closer, this is where all the Minutemen bases were located. So it's basically pointing right dead center on these nuclear missile bases. And this is a map from 1988. And when they were tearing down the site, that you could see on the floor a lot of different debris, and there was a map that shows the North Pole. And they were on the air saying in the middle of the movie and to many people around that this antenna was pointing just the opposite direction, not at the United States. And you would not use a polar map if you weren't going over the North Pole. So the answer is yes, they were looking at us, no doubt about it. And here's a little bit of a screenshot of the spectrum, and you can see the chirping, three or four different frequencies. And over here you can see this is the Duga 3, which is in the Ukraine, and they would have another site over here, and they would crisscross the United States to make sure they covered all their bases for the nuclear missile launches. So is it the biggest? No, the largest antenna is Arecibo in Puerto Rico. Is it the tallest? WLW has a tower that's 831 feet tall, so it's not the tallest. The most powerful? No, Duga is not as powerful as the HARP array, which is in Alaska, which is 3.6 megawatts. Is it the most expensive? It may be. It was 7 billion rubles at the time, and that's about $600 million in today's currency. Was it heavy? Yes, it was one of the heaviest. And pretty, well, this is a matter of opinion, I guess. So you're going to need a prettyometer to find out if it's the prettiest. Here is the site of the Chernobyl nuclear accident. This red star is where the Duga 3 antenna is, and Chernobyl, the city, is down here on the bottom right. You can pretty much tell or find the Duga 3 array by finding the cooling pond from the Chernobyl nuclear power plant. So this is the cooling pond, looks like a finger. So all you have to do is go to the west of that finger lake there, and you'll find the Duga 3. It's not hard to find, it's so huge. The information that they were giving on TV, radio, newspaper was that the Duga 3 was a receive antenna, which I'm going to say it was not. I'm going to say that that was misinformation. And in addition to the transmit antenna, you need a receive antenna. And I believe that the receive antenna array was up here I can't pronounce it, Liebeck. And that's probably the where the receive antenna was located, though they were saying that this was the transmitter and this was the receiver. So who do you believe? The question is, you know, there's so much misinformation going on. By the way, this green area here is actually here is a stay out zone because of the nuclear radiation from the Chernobyl explosion. So this green part's where you stay out. So here we have, you know, different effects. What if it was transmitting? There could be possible health effects to pregnant women, and different people may have problems with electromagnetic interference could help in the buildings. And it was transmitting at 10 megawatts, so that's a lot of power. And in order to keep this antenna running, you would like to have a source of power that's dependable, especially during a war. So that's probably why it was near Chernobyl. Some people say you need all that power from Chernobyl just to power it, but that's not a valid concern there as far as how much energy you need. You just need reliable energy. And then as far as the receive antenna, it wants to be in a quiet zone. So that one city up there in the northern part was a farm town. That's where you would put your receive antenna. And the high power antenna in the near Chernobyl would overpower anything else in town, so it wouldn't have any problems broadcasting. So that's why we think that the misinformation was being spread. And to be sure, the people from Australia, they used their capabilities to triangulate, and they found that yes, indeed, the transmitter was the Duga 3, and that's a few kilometers southwest of Chernobyl. And it had the code name 5H32, a repetition rate of 10 hertz. So it's ticking away 10 times a second. Sometimes it was 16 or 20 times a second. And the bandwidth was 40 kilohertz. So if you think about it, the triangulation is really the truth of the matter. And they were just using misinformation. Most of the time they said that this thing was a boys' camp or something else like that. So nobody was telling the truth. The Chernobyl power plant, you can see from above, here's the, they're making a metal cage here that's supposed to go over this blown out reactor here. They're actually sliding this over the top of the blown out reactor. And this is the cooling pond. And these are the cooling towers. There's the cooling towers here. And now you can see the array, the large array. I'll go ahead and do some analysis with it, and the small array is right next to it. And here you can see just one dipole out of 300. And in respect to the tourists that are looking at it, people were giving tours of the Chernobyl power plant, and for extra money, you could come and see this antenna. And these people paid their money, and they do see like one of the 9th wonders of the world. I'll tell you, it's just so huge.
Question for you.
Yeah, go ahead.
On either end of the antenna, there's some smaller, well, smaller, tall, but narrower single vertical towers.
Oh yes, those are holding up this. You see these wires here?
Yes.
It's holding up a metal screen, which is behind the cage dipoles. So it acts as a reflector.
Oh, so you're saying it transmits through all that material?
The energy comes from the dipole
Right.
forward. Any energy that's going back towards those wires gets reflected and goes forward as well. And there's a perfect distance in order to get a better, higher gain for a dipole. And that's a very good question, by the way. And it actually follows right into what I'm going to say.
Yeah, I think if you look at on the upright pole to the left of the dipoles, you can see a bunch of little nodules on there. That's where those wires must be running. They're on our side from our view of the dipoles.
These are the twin leads here, twin leads coming from here to feed this dipole, and they go up to the next one above. There's like each column of these antennas has a pair of twin leads that are in the shape of a V or a Victor. So let me go ahead and keep going, and we'll look at the geometry. Yeah, these are the frequencies. First at 18 meters, it's 16.45. And in the order of which they were transmitted, 16.45, 16.49, 16.57, and 16.39 for 18 meters, and then 8.07, 8.23, 8.31, and 8.26 for the 36 meters. So when you think about the lower frequency antenna, it's hopping around, and those are the orders in which they were hopping. But I'll go ahead and get back to the geometry. If you look up, you see the screen again very well now, I think in this photograph, placed behind these dipoles, cage dipoles. And there are the cable runs. So you get, there's a support and then twin leads. So each row of these antennas is being held up by a support cable and then twin leads that form a V. And I'll talk about that. Plus they were squished together as close as they could so they don't get grating lobes in their antenna pattern. That's what happens when you have phased arrays. So you try and get the antenna elements as close as together as you can. Here's the feed box. Obviously this is a pretty big monstrosity. And if it doesn't, you wouldn't need something like this if you were just receiving. So we believe this is highly insulated, and for transmitting. Here's a close-up of the twin leads that feed each of the dipoles, and then just above is one insulated weight support cable. So this help keep the spacing in the vertical dimension and help support the weight as well, and make sure that the feeds are kept in the same place. Here it is again. And Steve Sturm says that if you have these open wire type feed lines, that they should have an impedance of 275 ohms. And he's kind of a doctor, so I'll leave it to him to be making that calculation correctly. And then you can see also that the dipoles themselves are supported by big tubes, metal tubes, and you're coming through the cage itself, and you're not touching on the sides, but in here you must have an insulator. Right in this region, they have done something with exotic materials in order to insulate the cage from this arm, support arm. So that's something new, and it's pretty amazing that they were able to do that for all 300 of these dipoles. And then here's another close-up of the insulator. This is the one that is holding the one below, and then this is the twin. It's got a plus and a minus, so that'll feed the antenna elements in the right phase. Now here's a diagram of the in a Russian book by Sergei Nadenenko. And this is the original Russian diagram in his book of the cage dipole and how it's fed with the twin leads here and supported on either side with insulators. And if you want to make one yourself, it has the dimensions that you need to make it in wavelengths. MAKC in the writing here, it means maximum. So, and also this business over here says it's insulated or shielded. So here you get a good look at the dipole again, just one half of it, and how it's supported. And I digitized this shape and put it into my computer code. The full length of the dipole is 25 meters. Again, 300 of these. So that's a lot of metal.
Interesting on your last slide, the one prior to that, they show that as being fed by coax.
Yes, that's right. You're right. Mm-hmm. So they fed it in a little slightly different manner. But yes, I was trying really hard to see if it was fed that way, but I could not see that. Let's look real close. I don't see the coax in this, but I do see the twin lines here.
Yeah, it's like they changed their minds.
Yeah, they did. Those,
no, we're gonna feed it with twin lead instead of coax through the inside.
Right, exactly. Good point. Nice spot. So I went ahead and calculated the response of just this is what's called the reflection coefficient, and in dB, and the lower it is, the more better. Let's say that in incorrect English. And so the blue line is just the simple dipole, and you can see it's got narrow notches where it's good. But with this cage dipole, the green trace has more, it's basically radiating more energy. And it looks really good in between, say 5 to 15 megahertz. And here's the VSWR of this type of dipole, cage dipole fed with 275 ohms. So it's got a good bandwidth. It's not perfectly matched like you would want, so I'm sure there may have been some tweaking going on. And again, here's the perfect distance is 0.18 wavelengths from the dipole to this metal screen, and at 8.26 megahertz, which is the lower frequency for the larger antenna, that's 21.43 feet. And this will play into the V feeding here. I'm going to go in and see how this is fed now. But first, let's make sure we prove that the gain of an antenna gets better by putting a reflector behind the cage at this distance. So what I'm going to do is calculate the pattern of the dipole with a reflector. And this is the pattern. The green trace has more gain or directivity by about 4.58 dB. So it's has more forward gain than just the standard dipole without the cage. I mean, the cage dipole without the reflector. So you can see the reflector is adding 4.5 to 4.6 dBi gain. And if you're pointing towards the United States, that's going to help you a lot. It's more than half the power. And then again, you can see the cage dipole versus the cage dipole with the reflector in terms of the gain, realized gain, and it looks like between 8 and 12 megahertz, it's got quite a bit more gain. This is frequency and this is gain. So it does help. Now this is in case anybody had a lava lamp when you were young. This is the radiation of a cage dipole by itself without the reflector. Looks very nice. The radiation is just coming out in waves from the dipole. And let's see what happens here. This is the same dipole with a metal reflector behind it at that same distance. So it's turning out to make it to be a directive antenna pattern, basically. So the screen is really helping quite a bit in terms of directing the antenna pattern. So now I'm going to talk about this V part. Here's the twin leads, and it's going to one above and one below. And you can see they have a common feed point here. So this line here has to be the same phase as this line here, only The thing is, they twisted them. So the one on the bottom, the red line's on the left, and the one on the top, the red line is on the right. So this is how they magically get these two pairs of antennas to be in phase. And Scott Burnside is the person who works with me who said, yeah, if you twist the pair and they're exactly a quarter wavelength, then they'll be in phase. So if I take the geometry, 0.18 wavelengths, and that's the magic dimension from Steve Stearns, and you take this distance here, which is from my AutoCAD dimensions. I put this into AutoCAD and I found out what the C dimension is. It's 20.8 feet. So we have these two sides of the B and the C. It turns out this A distance in terms of wavelengths turns out to be exactly 2.51 wavelengths or a quarter wavelength. So we can actually look and reverse engineer a Soviet antenna, which I used to do for a living when I worked at the GTE in Mountain View. So let's just see what happens if we calculate some antenna patterns. I think I'll do that now. This is the AutoCAD that I used to mensurate the antenna and reverse engineer all the dimensions. And these are the dimensions. The dipole length is 82 feet. I'll just go into meters here, 25 meters, and just basically pulled out the different dimensions, vertical spacing and the height and the length of the dipoles. Now I entered all that into FICO, which is my computer code to calculate its moment methods, basically, with the addition of being able to do it over the Earth. And at 21.433 feet, that's the distance for the screen to be behind the dipoles. And I'll calculate 8.26 megahertz, see what kind of antenna pattern I get. The sand again was used in this calculation. So I used epsilon relative of 2.55 and a loss tangent 0.0062 as part of the input parameters for the soil. And this is the first look at the antenna pattern coming off of this antenna. The red is around 30-ish dB, and then when it gets blue, it's about minus 15 dBi. And you will notice that it's got a pretty strong front lobe and a pretty strong back lobe. So if we're looking at the United States, somebody in Saudi Arabia is also getting blasted by this antenna pattern. This is the antenna pattern in elevation. So it's got a peak of 29.4 dBi. This is pretty much unheard of at this frequency. You know, at 8.26 megahertz, how many people have a gain 29 dBi? And it's launching at an elevation of 6 degrees. And if I go to the azimuth pattern at that elevation, this is the antenna pattern plotted from 30 to minus 10 dBi. And it's not so bad, I guess, but if you plot it on a scale of 30 to minus 30 dBi, you can see that there's only like two directions where it's not radiating. And that's why this antenna was blasting all over the world, basically, interfering with people's communication. Even SOS signals were being interfered with. And here's a look at the antenna pattern just from above. And I'm going to use the green screen technique and erase the green and stick this onto a map. And here's the finger of the cooling pond. And you can see this is pointing towards the United States. And this is pointing basically towards Saudi Arabia and India. They're not very happy either. So it's covering the United States, hitting it really well with 10 megawatts of power. And this is just a little bit of radiation hazard calculation at a height of 5 feet above the ground. This yellow and green is high radiation intensity, and blue is cool, not so bad. And we can just do a little bit of manipulation here. Here's the front of the array. Yes, go ahead.
Yeah, this is Mark again. If you go back to the radiation pattern that you superimposed over the map,
yes.
Where was the town compared to that radiation pattern?
Right here's Chernobyl right here. But there are buildings right next to this facility.
That one.
Yeah, right next to this facility, there are buildings for the military.
But
So
even so, it looks like some of those side lobes,
yes, yes.
if you look at where Chernobyl is, some of those side lobes were pretty serious, even, you know, even though they were side lobes.
Yeah, I think that you're right about that. And, you know, it's just kind of this plays into the, what do you call it, when you get really paranoid about a problem. Well, if it really was a problem, this guy from the Ukraine was saying, you know, they may have been trying to hide something. Maybe this antenna was hurting people. Maybe that's why the Chernobyl accident wasn't an accident. He's claiming that it wasn't an accident and that it was intentional to cover something up. And part of it might have been the cost of the array, or the fact that at 4 megahertz it was not going to work due to the northern lights, basically.
Well, I've always said you can save money if you can read by your own light.
So here's the Earth. They actually have a fallout bunker here, a nuclear bunker, and these buildings here, there's a military parade ground right next to this antenna. And if you superimpose the array on top of these buildings, these are red lines that go over these buildings, and you look for a limit of 22 dB volts per meter, which is the maximum you're allowed. That would be somewhere in the green to yellow region. So anything that's sort of greenish yellow is not good to be dancing around in. And there's a building on the other side of the road that's definitely being blasted by the more than 22 dB volts per meter. So yeah, they may have been doing some over the limit kind of broadcasting. Yeah, at 10 megawatts, that's a lot of power. And this is just showing that
they have to spend a lot of money on heating their barracks. So they were getting RF very directly.
I know a guy that was heating his hand when I was working at Whirlpool on microwave ovens, and he was coupling into the waveguide. His hand was getting warm. Yeah. So Duga actually means arc, and the arc is right here. It goes up to the ionosphere, hits the signal hits the ionosphere and comes back down. And hopefully it's only one bounce, but it may be two, depending on. I would expect that one bounce should be sufficient to hit the United States. Again, we could steer this beam up, and I sort of did some calculations to find out what is the phase that I might want to use to steer the beam up, angle of 30 degrees, and the phasing was 31.45 between elements like 1, 2, and 3. But after doing this, I don't think they really steered the beam up. I just thought I'd show you I can at least steer my beam up here and show you that I can do calculations. So my degree from Ohio State's still good. And let's see. So the pattern looks like this. The side lobes come up with it. And you can look at it from the side. And you can see again, if I was to overlay the near fields here, they're better because you steered the beam up. So it's a little bit less problem here, at least for these buildings.
So do you believe that they did any kind of phase control of this thing, or was it all just?
Yes, you know, the fact that they're chirping at 4 different frequencies, I think that they were doing azimuth scanning. So because all of the elements were probably in phase up and down, but between each column, you could put a phase shift, and that would diddle the beam, or what do you call it, left and right.
Yeah, you can just sweep the beam side to side.
Yeah, side to side, yeah. So I think they did a little bit of side to side sweeping.
Very cool.
And then let's see here. This is a little more patterns. That's okay. It's at 8.26. So that's the steered up beam. But I do show you a little bit more of the Earth and where we're going over Greenland. And then I'm thinking that we only get one bounce to the United States. But it all depends on the atmospheric conditions at the time. But again, if you have coming, and you're down here in, you know, there was, gosh, one of the princes down in Saudi Arabia used to have a ham license. He was very much into ham radio. That could tick off your neighbors, basically. And it did tick off just about everybody in the world. I'll do a real quick, fast pattern on the smaller array, but it's about the same thing. You go through, it's a scaled antenna, so go past the dimensions, look at the elevation pattern. It's got 31 dB at dBi at 4 degrees elevation, and it's doing the same thing. It's basically the same type of pattern because they scaled the antenna pattern, or they scaled the array basically. But this antenna had a few less elements. I believe it's only 10 by 18, so it's 180 elements versus 300 elements. But at higher frequency, you can use a smaller antenna and still get this 31 dBi gain. So then Chernobyl happens, and we have the story of, did this guy really blow up on its own, or was this some kind of directed action from Moscow? You can see these buildings are so close to those antennas, by the way. So yeah, I'd be kind of nervous about my, if I had not already had children, I'd be a little nervous, let's put it that way. And then there was a lot of disinformation, and they used to call this a children's camp, and the installations had fake numbers and identities. The Russian Woodpecker movie is a documentary about Fyodor Alexandrovich, and he's the one who believes that Chernobyl was staged by Moscow to cover the failure of the Russian Woodpecker, which cost 7 billion rubles to build, and that's a ton of money, especially for the people in his country. So now it's time for questions because there's more questions than answers. And if you see anything, let me know, but you can start asking questions anytime here. This doctor that was involved with the movie said that the Duga technology was unique. It was made of semi-precious metals. All the devices and receivers, especially transmitters, were also specially built, and the transmitters were 2 stories tall. So we're talking megawatts, and he's talking about special computers that had to be built. They weren't, you know, mass produced. And all of that went in, and cables and amplifiers and phase shifters. So this phase shifters makes you say, okay, probably it is being steered left and right. And so he's saying none of this is, you know, this is all expensive, very, very expensive. And then the commander, he's the one who was saying the antenna was pointing the other direction. So I don't necessarily believe everything he says, and but he was just saying it's just to make sure that the Russians have a counter strike capability in the right amount of time to launch their response, and that's the reason why it was built. But it used to be known as Chernobyl 2. It used to be known as so many different things, and the Ukrainians were not allowed to talk about it at all. And he's the one that said that that the Duga array was a receive array. So he's saying it's a signal receiver, and I'm saying not really. I don't think so.
How many people do they think were in Chernobyl, the city? Was it tens of thousands? Or?
Yeah, I think so. Yeah. Now, it's a pretty good city, a very nice place to live, according to the movie. You might want to check out the Russian Woodpecker movie. You can see it, I think, on Amazon for $3 or $4. But in the movie, the colonel mentioned that the antenna was failing, and it was going to fail because of the aurora borealis. And aurora borealis is really only affecting certain frequencies. And I'm in the defense business. I'm not allowed to talk about frequencies. So he didn't talk about frequencies, but by mentioning the aurora borealis, he just mentioned the frequency. Right?
Yep.
Yeah. So in order to block the inspection of this antenna, they believe this diplomat from Moscow ordered the workers to perform the deadly tests of the nuclear power plant. And the day workers said, no, we're not doing it. But the night crew said, okay, we'll do it. Or maybe it was just because it was the shift change. Maybe they didn't get their signals correct. But it had to do with turning off the electricity or turning off pulling the rods out, and depending on the spinning wheels to keep the electricity going. And it was a kind of a fiasco. So in my mind, I believe that they really did a stupid thing, and it was probably just a coincidence. But in the movie, they believe that the person who was going to waste $7 billion would actually be shot. And they meant it literally. So that's why they may have wanted to cover up and not have the inspection. So I'm not sure. There's some talk about how it was just doomed to fail from the beginning, but I don't think so, because it was on the air for 13 years. So I'm not going to buy all of it, but you know, there's a lot of disinformation out there.
But we also never launched ballistic missiles from the U.S. towards Russia. How would they know whether it worked or not? For sure.
Oh, that's a very good point. They watched every launch of the shuttles.
Oh.
They said in the movie, the colonel says, we saw every one of your launches. So it has to do with the plume of the rocket itself, affecting some of the ions and things like that.
Mm.
This is a plot of the aurora borealis, and this is an old chart, but it says that the aurora is affecting frequencies from 3,000 to 4,500 megahertz. So this is the region where the aurora borealis is affecting the signals. And so there's auroral roar, if you can say that, and these frequency bursts here, medium frequency bursts. And if you look at it, the aurora roar was 2.8 to 3 megahertz. Harmonic roar was 4 to 4.5 megahertz, and et cetera, et cetera. There's a little bit of hiss in there. So this is possibly the reason why Duga 3 failed, but it may be that the satellites were already up and taking over. You don't know. So let's guess their new frequency. They said they were going to go on the air. They did 16, they did 8. And you would guess that if you're going 16 and 8, you might go down to 4. And then you could, but it had this aurora roar, and maybe it was not working. And here's a plot from Boulder, Colorado, of the time of day, starting at the 0 hours to 24 hours. And this is the frequencies on the left side. And as you go through time, you can see that these are the frequencies between 4 and 6 megahertz that are being affected by the aurora. And if you think about it, the aurora is over here at a certain altitude, and it comes at night. And so basically, you're being shut out at nighttime. But the F layers and all those layers that we're used to using for ham radio, you know, they're shown here as well. But what happens is this aurora roar, or the aurora itself, is kind of shaped like the top of an apple. And that would keep you from getting your signal from the Ukraine through this mess over to this mess through this apple-shaped interference. It would have reflected at a different angle, and you wouldn't have gotten to your target. So that may be the reason, but we do know that the Soviets were using 3 to 30 megahertz on these antennas, and they were pecking away, and everybody in the world could hear it. And I looked at maybe if they did use a dipole, it'd be like maybe 102 feet. And maybe they could have stuck it in here. Maybe you see these things here. Who knows what these are? So maybe they had some horizontal arrays going on in the back screen behind these antennas, and maybe they were trying 4 megahertz. And you see they had, looks like they have insulators or something, you know, looks like this is a rope and this is maybe some kind of antenna, perhaps, I'm not sure. And there's the right side. So you don't know for sure, but if they did, this is the antenna pattern they would have gotten. I love to calculate patterns. And it would be launching at 10 degrees elevation and have a gain of about 23 dBi. And that there I used 15 elements across. I didn't use as many elements. I used 150 elements by 10 elements high. I was trying to sneak them in behind the other dipoles. And that's the antenna pattern again. Again, that's azimuth pattern. And pretty much we come to the conclusion that they were maybe looking at 3 different launch angles to make sure they could cover all of the missile bases. And here's my conclusions.
Wouldn't that also compensate for variations in the height of the ionosphere?
Yeah.
They could change their azimuth or their elevation angle and
You're right.
compensate for the ionosphere being at different altitudes.
Yeah, you're absolutely right. I mean, according to some of the articles, they say that the Russians did not understand the atmospheric effects before they started building this, at least the 4 megahertz. But it could have been even the other ones. But you're right, it's a dynamic elevation or altitude.
Okay, and you said that they didn't have the ability to phase.
I don't think they were able to phase in elevation. So probably they were looking for, 3 different launch angles. Yeah. So if you do want to go there, if you ever want to contact me, I can make this available. And I put an antenna on my Snyder. And but let's see if there's anything else here. To find the woodpecker, you just go to north of Kiev and use your Geiger counter. And when you find the highest reading, that's at the Chernobyl nuclear power plant, and that'll be the burned out reactor. And just go south of the cooling pond and 4 clicks to the west, and you'll find a giant drive-in theater with sand on the ground, and just bring your lounge chair, okay?
A couple of questions.
What was the timing of the dates between the Chernobyl nuclear incident and when the woodpecker went off the air? I've lost track of time. What are the dates of those 2 events?
That's a very good question. I think it stayed on the air well past the nuclear explosion.
Okay.
Yeah, even though the people were being radiated, I think that they stayed on the air.
Okay. Thank you.
And here's a close-up of that shield that they're going to put over the. This is the burned out reactor, and this is a big shield that's the sort of a cylinder, half a cylinder. And here's a picture of one of those cage dipoles with a tourist next to it. We're not small. And here's that shield again on the ground, and the burned out reactor over here. And here you go. If you want to be one of the tourists that go over there, you can actually see the power plant right there. And to get a good view, you can just walk right out here if you'd like. Any takers?
Maybe on the lowest rung.
Thank you anyway. That was a very nice offer.
Are you open for some questions?
Absolutely.
WB6IQS.
You can see the V here, by the way. Here's the V feed coming down from one down to the next one. Yeah. Go ahead and ask a question. Go ahead.
Okay. A couple of questions. Are they, by any chance, hooking a transmission line into that? I know that at some of the old sites up in Central California where they had the Voice of America and that, they're allowing hams to tie into the antenna. that would be quite an antenna array if you could hook into it with your HF transceiver.
I'm sure they are. Yes, definitely they have been. I know they have been. They've been, giving certain people access to, one or two element at a time, just to use as a, regular ham operating.
And then we had a ham years ago that was a member of the club that used to work at HCJB in Quito, Ecuador. And they did a lot of high frequency broadcasting. And they had a long periodic antenna on a central point where they could steer it by moving a train around a round train track.
Wow.
And the long periodic antenna was anchored at the center, and then the train ran around the outside and they could steer this HF radio. I'm surprised that the Russians would go through all this work, effort, and trouble and not try something first, like build a prototype. It just seems incredible.
Yeah, the theory that they blew up Chernobyl intentionally, I'm not buying it. But the movie will try to sell you that. But I think that what happened was the satellites got up in time, and basically they were phasing out this whole system, and they probably just used this. It didn't work as a cover story. That's my guess.
This is Mark, KF6WTN. You've been talking a lot about Duga 3.
Yes.
But there's also Duga 1 and Duga 2, which were in different places in the Soviet Union.
Right.
Did you want to mention those at all, or?
Well,
John was talking about maybe why didn't they build a prototype?
I think they were all functioning fine. The other two were just disassembled. This one didn't get disassembled because of the nuclear power plant explosion. Due to the radiation, it was saved. But yeah, I know that I got some communication from one of my ham radio people that were in the audience that he knows and has been to Duga 2. And if you want to hear anything about that, I could probably forward his email. But he said he'd have to come over to the United States. He was in Australia, and he worked on the Australian over the horizon radar. And he definitely was there at the Duga 2. Yeah. Yeah, they had all kinds of crazy things going on here as far as the antenna is concerned. And the people in the city were just not allowed to talk about it, or they could be thrown in jail. The person who did the movie about the woodpecker, the Russian woodpecker is the name of the movie, saying that it was a conspiracy. They threatened his son, basically the KGB type people, police of in the Ukraine were threatening him. So he was basically scared to death. Yeah, I'm not sure if there's anything else. Yeah, I do have one more slide where I can show you not an over the horizon, but a line of sight array. That's our pave pause. That's there, and that's a bunch of little circular polarized antennas. So anyway, I thought Ty Theory with that. But that's a line of sight antenna, circularly polarized. Yeah. But yeah, the Duga 3 was just tremendous. I mean, 15 football fields in size, just crazy big.
There's all those buildings, and there's some pictures of some of the maps and stuff. But what's the theory about where all the transmitters? What happened to the transmitters themselves?
Oh yeah, you can go on the web. There's still a bunch of. I mean, basically everything was scrapped. But you can see metal boxes and all kinds of stuff laying in the snow.
Okay, so they're still there.
Yeah, they were ransacked basically.
Yeah, but they weren't removed.
I suppose they would have removed, if you were a normal engineer, you would have grabbed whatever was of value to you,
Yeah.
that kind of thing. But yeah, I mean, just imagine 15 football games going on at once on your antenna.
A question about Alaska. There's stories about a megawatt radio station up in Alaska that they're talking about weather modification and other crazy things. Is this the United States equivalent of the over-the-horizon radar, do you think?
I'm sorry, I don't know anything about it.
It's the HARP. That's called the HARP system, and it shoots pretty much straight up for ionospheric things. And a few years ago, they did a thing where they bounced signals off the moon, and you could receive it. It was on HF. You could hear it going out, and then the echo coming back.
Yeah, that's right. It was HARP, H-A-R-P.
Right.
They're doing megawatts of HF transmissions.
Oh yeah,
up in Alaska.
Yeah.
Yeah, that's yet another really impressive project.
Yeah, 3.6 megawatts.
Yeah, that's and they're all facing straight up. There's a whole lot of conjecture as to exactly what that is. And even back when I was involved in all that wild and wonderful stuff, nobody ever talked about HARP.
So this slide right here, question about this slide. Most powerful says no, but 10 megawatts is certainly higher than 3.6. I don't see why that is a statement there.
Effective isotropic radiated power versus total radiated power. I think that this means it's higher instead of this EIRP.
Yeah, the HARP didn't have such a high gain antennas on it. They were pretty compact.
Yeah.
So you're mixing units there then?
Yeah.
Not me. That's one of the worst things. I had John Krause at Ohio State. He always said use your units. Make sure you show your units. And you're right. Yes, that is a mix there. But actually, this slide was made by Steve Stearns, so I can blame it on him.
All right. Well, I guess
I have a question.
That's what I was going to ask. Go ahead.
This is Bob, KK6EVD. How does this compare, or do you know anything about how it compares with the BMUS system that the United States has had for the last 50 years at Clear, Alaska, and Thule, Greenland, and I think one other place in Europe? Do you have any idea how it compares with that? I mean, that was a ballistic missile early warning system that predates this and is still in existence and operating as far as I know.
Yeah, I have big cages on the ground, kind of thing, big wires. I know I've seen pictures of them, but I have not analyzed them before. But that's good homework for me. Anybody in the group can answer that besides me.
This is WB6IQS. I've read some books and things about the Cold War, and I think that was all microwave as opposed to over the horizon stuff. The reason that they put it so far north was because they wanted to see it as early as possible as it came up over the horizon.
Oh yeah. So they put it around as close to the north as they could. I guess you're right. In a circle. There is a mention of that in the movie that the Russians were building this antenna in response to the Americans building their antennas.
Yeah, the reason I ask is I was stationed in Alaska 100 years ago, well, in the 60s, at a radar site, but it was just for aircraft surveillance of eastern Siberia or west, whatever, the Bering Sea in that area. Mm-hmm. So I wasn't far from the BMUS site, but I never went there.
Well, Keith,
Yep.
This is, as you know from my background, I guess I should turn my video back on.
Oh,
As you know from my background, what can I say? I've always been really interested in the harp, in harp and in the woodpecker. But woodpecker makes a much better background than harp does. And I want to thank you very much, unless there's more questions, for the presentation. Of course, it was absolutely riveting for me.
well, good for you.
You know, so yeah, thank you very much.
Okay, yeah.
We'll do one last. Yeah, thank you very much.
Hit the like button.
Pardon me?
Everybody hit the like button.
Oh, okay. Anyway, it was
AJ6IT with a comment.
Sure, go ahead.
Yeah, I wanted to say, name's Steve here. So in 1990, I actually visited the Soviet Union. I was there. I have family in Gorodenka, Ukraine, relatives there from the old country, also in Poland. My mom was a Russian teacher. I took a half year of Russian. The one slide that you showed there with the azimithal map, I can actually read the Cyrillic on there, and it said nomenclature topographic. If you, I don't know, that one slide, if you bring it back, if you look at it, it's almost like Greek a little bit. Right there. If you look at it, it's like homen, H-O-M-E-H, that's nomen, clatura, and then the next word, the T-O, and then the what looks like a upside or like an N is a P, so it's topo, and then the upside down L is a G. So graphic topographa. I can't read the like a circle with a line is an F. But yeah, I thought it very, very cool and awesome. I was there. I was trading sticks of gum and everything like that for pins, jeans, T-shirts, everything like that. A lot of surplus from the Afghanistan war. I have a really cool the trench coat, the wool trench coat with the epaulettes, with the hammered sickle. Really, really cool. You know, it was a great time to be there. In the Soviet Union, we flew Czechoslovak Airlines. We actually had a missed approach flying into JFK as well. So we got a good, we can only do that plane once a week, or that flight once a week, on an Ilyushin 92, I believe it was. It had double engines, four engines, nacelles, two nacelles on the, after the engine, kind of like an MD-80. So I just want to share that with you guys. Great meeting. I will be becoming a member of PARC here very shortly. So I just want to say that message. So back to you guys, AJ6IT.
You're muted, Mark.
Hit the unmute button. Okay. What I said a second ago is, Steve, thank you for joining in, and feel free to join in on any of our activities. In case it wasn't totally obvious, you know, our club is open to everybody. Our purpose here is just simply to further the amateur radio hobby / art, and spending an hour or so looking at one of the biggest, baddest transmitter arrays that's ever been created was a blast. So with that, considering I have a button here that says everybody can go home, I'll do what I normally do. That is, I don't think Joe disappeared. I'm not sure if he made it back.
Back.
I think he is back. Okay, you wanna do the voodoo you do?
Sure, I will do the voodoo I do. So thank you again for the presentation. It was amazing. Tons of good information. I did drop out there for a little bit. I had some family stuff I needed to take care of, and now I'm driving. So, but I got the beginning of it, a good portion of it, and the end of it, and I can go back and watch the recording. So thank you again for that fantastic presentation. Mark, you can go ahead and stop the recording. Reminder that next month is our auction. So if you didn't hear the instructions earlier,